Hello, Mario! In this video, I'm going to solve an equation with negative fractional powers. This video has been sent in, this problem has been sent in by a math student, and they've asked for a little bit of help from it. So it looks like a pretty tricky problem, so obviously they've tried a few things themselves and not quite sure where things are going. So I'm going to try and solve the problem for them, give a solution to the problem, and then hopefully they can maybe choose a similar problem and solve that as well. So let's see how things go. So let's first of all see if we can find the problem here on good old smooth draw, and let's put it up on the big screen so that we can see. So here it is, and it is c to the power of negative 3 over 7 all divided by 4, which I've actually left out at this point. So that's over 4 like that. Yes, plus 2 equals 5. So I'm just checking here. Yes, that's the problem there. So it always pays to check the problem that you've written it down correctly, especially if you're doing it for an assignment or some sort of assessment or something like that. So the first thing that I sort of seeing here is I'm seeing this number here, this plus 2. Oops, I wanted to go to a different color for that, green. So I'll just do an undo here. Yes, now we're in green. So I can see that plus 2 there. And straight away, I can see that if I take plus 2 from both sides, so I'm going to just over here, I'm just going to take negative 2. So just do the opposite, plus 2. So I'm just going to take negative 2 from both sides, which of course will take out the plus 2. So let's go back to red here, and so we're going to have c to the negative 3 over 7. I'm going to take that bracket away. I don't sort of need that. All over 4. I'm just checking my problem here. Yes, all over 4. Now that's going to be plus 2, and I'll go to green for this. Minus 2. Okay. And then back to red, equals 5, and back to green. Oop, come on, green, minus 2. Okay, so that's just taking 2 from both sides, and of course that's still all over 4. We mustn't forget that. So that now means that the equation, remember that the equal sign is all about equality and the equation being true. So as long as we do the same to both sides, we get c to the negative 3 over 7 all over 4 equals 5 minus 2 is 3. Okay, so there we are. Now the next thing that I want to do is I want to go to green, and I want to multiply by 4. Because I'm dividing by 4, if I multiply by 4, that's going to get rid of the 4 on the bottom here, and what I do to one side I must do to the other. So let's go with red here, and we're going to just go c to the negative 3 over 7 all over 4 go to the green, times 4 over 1 if you like, equal, and then back to the red, equals, so the green is equals 3, and then back to the green, times 4. Okay, so that means the 4s are going to cancel out. If you, I'll just put a little, what colour am I in? I'm in green, so I'll just put a little cancel, because they'll all cancel out. And then 3 times 4 is 12. So now the equation, or the truth becomes c to the negative 3 over 7 equals 12. Okay, equals 12. C to the negative 3 over 7 equals 12. Now, this negative here seems a bit of a problem, but that's easily solved because we can use our powers of indices. So, oops, let's undo that. So let's go with a yellow, and let's just say a, so this is just like a fact, a to the power of n equals 1 over a to the power of negative n, and vice versa. So I'll put it here, a to the power of negative n equals 1 over a to the n. Okay, so we can see there that c to the power of negative 3 over 7 equals 1. So I'm going to just go here. So using that fact, 1 over c to the power of 3 over 7. So that's got rid of the negative, which is always hard, equals 12. Okay. Now I'm going to just hopefully draw a line up here, almost vertical, and I'm going to go over here. And now what I'm going to do is I'm going to I'll get my green pen out. What I'm going to do is multiply both sides over here by c to the power of 3 over 7. Okay, so what that's going to do is it's going to give us 1 over c to the power of 3 over 7, and my green here is my green, times c to the power of 3 over 7 all over 1. You can always put something over 1, it doesn't change it. Anything divided by 1 just stays the same. Equals 12. Okay, times, and you can usually leave out the time, times c to 3 over 7. And then you can see that that crosses out, and that crosses out, and then we get, and I'm going to swap the sides around again. This is, oops, let's go red, undo that, let's go red. What we get now is 12 c to 3 over 7 equals 1. and go through with our green here, and I'm going to divide by 12 now. Now there probably is a quicker way of doing this, and you might see that once you analyze it, but you can do all sorts of steps. As long as what you do is right, you're not going to get a problem. So I'm just going to show here dividing by 12 and dividing by 12, and what we get is finally C. Oh, I want it to be green. What we get here is C to the power of 3 over 7 equals 1 over 12. Now, how do we get rid of these powers? Well, this means C cubed, the 7th root of C cubed. So C is going to be here, if we use our surd or root thing, that's going to be the cubed root. Okay, so we do the opposite. So what we're going to do is we're going to, over here, we're going to go, I'll put my green in here. What we're going to do for this here is we're going to go, I'll put it like this, x, to undo the to the power of 3, which is there, we're going to go cubed root of x, and then we're going to also do the x to the power of 7. So it's the cubed root of x to the power of 7, which undoes the 7th root, and the third root of that cubed. So it's going to be like that, and then it's going to be, oh, let's undo there. Oops, go forward, young man. That's better. There. So, and then we're going to go C to the power of, oh, no, it's not. It's 1/12. So 1/12 to the power of 7. So we're going to just do the opposite. Or there's another way of looking at it, and I'll put that in here. And that's just going 1/12 to the power of, this is another way of looking at it, just flip this up. So it's to the power of 7 over 3, which might be an easier way of looking at it, but there's a couple of ways of looking at it. Okay, so then we can go C equals, and then let's get our calculator out. Here's our calculator. There it is. All right, so let's do this. So first of all, let's all clear. Let's go 1 divided by 12 equals. So that's all done there. And then we could just go into here and use this function here, x to the power of there. And in there, we could just go 7 divided by 3 equals. And there's our answer. And it's 10 to the negative 3. So I'll just put it in a decimal form. I don't know. I haven't checked this out, whether I can do that automatically here. Perhaps I shift mode fix. Oh, 6 is fix. And I'll go 9. Okay, so that's going to be C equals, oh, and this is where my little 0.003 0.003, where's my calculator? It keeps disappearing because it's the program changes. 0.03033 266 0.030 0.033 266, and that's 1 2 3 4 5 6 9 dp, 9 decimal places. And that, I think, is the answer, but you'd want to be pretty sure about that. So what you can do is go back to your little fx here. So that's certainly our answer. So let's just go back and check up here. So that's what C is. So let's go C. It's another way of let's go answer, and we'll do that to the power of -3 divided by 7. So here's our little power button here, and here's our -3 divided by 7 equals, oh, and that comes up as 12. Okay, so that's the little bit at the top, and then I'm going to divide 4 equals, and that comes up as 3, and then plus 2 equals 5. So there you go. It would seem that the answer is C equals 0.003033266 to 9 decimal places. So that's a little bit of a tricky answer, but obviously what we need there is some pretty good calculator skills to enable us to get the answer. So what I suggest you might do now is to set up some similar problems, maybe similar to this one, and just make sure you can work them out. And then once you do get the answer, just check back to the beginning and make sure everything's sweet as. So that's it. Cheers. See you.